Hi, this is Sai Orapalli. Today, I'll be presenting you my understanding of the solution for assignment 8 regarding bandits. So, in this assignment, we're going to solve the classic reinforcement learning for multi-armed bandit. So, in this case, so the problem here's a problem description. So, assuming we are in a casino with 4 different slot machines, and each slot machine has a 1 arm. So this type of situation we call as one-arm bandit, and each machine has its own probability, and every time you pull, you get either a success or a failure. So it's basically like a binary. So either you get a reward, or you get a success or you get a failure. So each machine has its own different kind of probability. So our goal is we're gonna maximize. Our goal is to maximize the reward function. So we're going to start by importing all the necessary libraries that we're going to need. So once we implemented the libraries, so first we're going to start defining our reward. So let's say the model takes an action. So whether the action taken is a correct action or not. So based upon that, we're gonna reward our model, or reward the action taken. So in this case, we're gonna define the probabilities for each machine, and then when a random action is taken, so we're gonna compare the probability of that machine, or when we decided to pull, let's say machine number 4, which has 80% of the probability. So then we're gonna generate a random number, assuming that's the outcome. So we're gonna compare that with the probability of the machine. Okay, if that is less than the, if the random number generated is less than the machine, okay, now I did the right thing. So now my reward will go up, I'm gonna get a positive reward. If it's wrong, then I'm gonna get the 0 reward. So we're gonna define our reward function. So using the code here, using the code shown here. And then once we defined our reward function, the next thing is we're going to define the quality value, and also the action should be taken based upon the quality value. So to do that, so this is the code given. So initially, we're defining a class, and initially we are making our number of actions as 0. We are zeroing the actions and zeroing the quality values. So this is where we're doing it. That then so for every action taken, it's gonna add up, we want to keep a count of total number of actions taken. So the self dot action track will keep a count. So every time when an action is taken place, so it's gonna keep adding 1 to it. And then for the quality value, so for each action, we're going to calculate the quality value. So what we're going to do is, so for each action, we're going to calculate the quality value, and for the action which has the maximum quality value, we're going to pick the action which has the maximum quality value. So to do that, to calculate the quality value, here, this is the algorithm, the equation how to calculate the quality value. And that is what we are implementing here. So quality value equals to 1 the quality value of that action plus 1 by total number of actions into reward minus the quality value. So this will give you the quality value for a action. And then here there's this epsilon function, where when epsilon is 0, it will do exploration. It will do only exploitation, and when ESP, when the epsilon value is 1, it's gonna do more exploration. So we're gonna look at that in the coming code. So this is how we define our actions here. So as we can see, so when we're gonna calculate the qualities value for all the actions, and then for the action which has the maximum quality value, we're gonna pick that action, And then based upon that action, we're going to get our reward. So this is where we implemented all our actions and quality functions. And then we're going to implement the episode. So in this case, we're going to implement, we're going to run the program for like 10,000 episodes. So for each episode, we have like 500 time steps. So for each time step, it's going to take the action. So as we could see here, based upon the, we are defining our action as like, okay, based upon the epsilon value, whether to explore more or whether to exploit more, it's going to take the action based upon the epsilon value, and based upon the action taken and the probabilities of the machines, it's going to give you the reward, whether you got a success or whether you got a fail. So once the action and reward are determined, we are going to update our quality value, and then we are going to sum all our quality actions and the rewards in actions per episode. So for each episode, it's going to calculate the total number of actions and then total number of rewards. So this is the function that was defined. And then now we're gonna set the parameters. So like I said, we are considering 4 missions with 4 different probabilities. So assuming one has 10%, 50%, other has 50, then the other one is 60, and then the other one is 80% probability of giving the success probability. And then so that the total number of arms are 4 here. So assuming each arm for each slot mission. And then the maximum episodes, okay, here it's 1,000, my bad, 1,000, and then for steps per episode is 500. And then here we are setting the epsilon value to 0.1, saying, okay, just do, so when it is close, when it is 0, it says no exploration, and when it is 1, full exploration. So we are just setting that value to 0.1 here. So I'm saying like, do a bit more exploration. And then once you find the best value, try to exploit it more. So once we set our parameters, so it says like, okay, rewards to collect 500, because for each episode, we are going to have 500 time steps. And then so same thing, we're going to have like 500 actions for each episode. So now we're going to run our program. So saying, okay, for run it for maximum episodes, so our maximum episode is 1,000. So for each episode, we're going to calculate the total reward, and then divide it by the steps in the episode to get the average reward per time step. So once we got our average reward, we're going to print it, and also we're gonna calculate the total reward for each episode, and also we are going to increase the total, calculate the total actions taken. So once we implement that, as we could see, for each episode, like when episode is 100, 200, 300, like for each 100 episodes, we are getting the average reward per time step. So in each case, like 0.6, 0.7, 0.6, 0.696. So as we could see, there is no like a linear increase here. So that means your model or the model is independent of the episodes here. So it's not learning from its previous episode. And we're gonna use the code to plot the graph, see how the model perform. So initially, we're gonna plot the result for episode. So we're gonna calculate the average reward per time step, and then plot it against the time step. See like how our model, how the reinforcement learning model try to learn over the time steps and try to get the maximum output or like the maximum reward. So as we could see here, so for one episode, like we have like 500 time steps. Initially started like around 0.18 or something. Our reward was that, and then as the number of time steps increasing, the total reward was increasing. And then we are gonna plot like how our model, or like what arm our model was trying to choose more. So here, as we could see, once we run the code for for the number of arms, how many times like each arm was chosen. We could see here like arm 0 was chosen for 6.19%, arm 1 for 5.84, and arm 2 for 10.45, and arm 3 for 7.53%. So as we could see here, when we set the epsilon value to 0.1, okay, it let's say it might have chosen arm 0 or arm randomly, it might have chosen one arm, and then okay, I got some value with this. And then what it's going to do, since we set it to 0.1, it's going to try to explore a bit more and see, okay, what the other arm, what's the reward of the other arm, and then what the reward of the other arm, and what's the reward of the other arm. Like it's going to see, okay, the probability of all the arms, and then try to, once, it finds the best one, try to exploit it more. So in this case, arm 3 was exploited more, and then and the model did explore the other arms too. But what happens when we set the epsilon value to 0? So in that case, okay, so in this case, I am set my epsilon value to 0. So that means we are saying, okay, whatever the value you got, just stick with that. Don't explore anymore. So as we run the code here, as we could see here, the average reward is like 0.1, 0.08. And once we plot our graph, seeing like, okay, how each arm was chosen, as we could clearly see, arm 0 was chosen 100%, and all the other arms were 0. So that means, so initially it picked arm 0. Okay, so whatever the value or whatever the reward it got, it just stick with that reward, because we set our epsilon value, greedy value to 0. So that means we're saying don't explore anymore. Like whatever you got, just stick with that. So in this case, it picked arm 0 and it just stick with that. It never tried arm 1 or arm 2 or arm 3. So similarly, when we set our epsilon value to 1, we're saying like don't exploit, continuously explore all the arms. So as we could see, like when we ran the program, our average reward was like around 0.5. And when we looked at the percentage of like how the arms were chosen, as we see here, like we set our epsilon value to 1%. So every time it tries to exploit, so you got like 4 arms. So it tried to exploit, try to explore every arm. So every arm got like, so 100% divided by 4. So you get like 25%, 25%, 25%, and 25% for each arm. So this is how, based upon the epsilon value, the decision will alter. Like, based upon epsilon value, you can, set your greedy, greedy level, like whether you want to explore more or you want to exploit more. So based upon that, you can, adjust your epsilon more to get the maximum reward out of the function. Thank you.